All right, folks, we're going to start projectile problems with projectiles launched horizontally. And so this is a side view, a stroboscopic image of a marble rolling down an incline. And you can see that it's speeding up because the distance between each image is increasing. And then it is launched out horizontally. So its initial velocity is only horizontal. It has no ups. And so if you looked at the distance it traveled each, whatever this is, 100th of a second, you would see that it's covering the same amount of ground horizontally. But if you focused on the distance it traveled vertically each second, you will see that it is going a little bit more vertical distance each second. Okay, that's a little bit harder to tell, but clearly this distance here, that vertical, is less than this vertical here. Okay, so the projectile's horizontal position is increasing at a constant rate. That's why the Joker landed back in the Batmobile. It was just going over at a constant rate. But the vertical position is increasing at an increasing rate. Sorry, I want to say an increasing rate. Okay, so you were going to make two physics Sudokus, and horizontally, you're going to set up, your X naught, your V naught, and you're going to say A equals 0. Okay, that's where people make mistakes. That's why I'm spelling out this type of problem separately. Because people look at the image and they're like, oh, something's going through the air. A is negative 9.8. A equals 0. There is no additional term here. So it's X equals X naught plus V naught T. But in your vertical Sudoku, you are going to have an acceleration of negative 9.8. For this problem, you're not going to have a V naught Y because it's launched horizontally. So that's the other mistake people make. This is a classic, or it used to be before they changed the AP. Don't know if it still is. It's a classic trick question where they have, or a multiple choice, where they're, it's an easy way to test, do some vertical, do some horizontal, show how they're connected. Okay, so again, in general, you're going to have the whole quadratic vertically. A is always going to be negative 9.8, but if it's launched horizontally, get out your aggressions, cross out that term. You will still use this because V naught Y begins at 0, but it will increase as it heads towards the ground. Okay, and then we've done this in free fall. So hitting the ground does not mean V equals 0. It means your altitude is 0. Okay, so if you're reviewing this before the AP and it's been a while since we've done that, ground is no altitude, not no speed. Otherwise, we could all go skydiving and land without a parachute because we'd hit the ground with no speed. Okay, hitting the ground does not mean no speed. Okay, you can look at that if you need to. All right, so you are juggling two things at once, a horizontal Sudoku and a vertical Sudoku. The only value that is identical in both columns is, and this animation doesn't work because I'm using Cami, time. Okay, so one way to think of this is you're going to do your horizontal Sudoku, X, V, A equals 0. You're going to do your vertical Sudoku, Y naught, V naught, Y, A equals negative 9.8. And if you find the time in one column, you can think of that as like a secret passageway, like if you played Clue growing up, a secret passageway into the other column because time passes the same, right? If we go back and look at that picture of the marble going off the table, time was passing the same, and at each instant in time, I had a Y value and an X value. Okay, so we've kind of seen this before when we did kinetics, when we did friction, right? F equals mu n, and that was the connection between horizontal and vertical columns for forces. So moral of the story is, if you're stuck on one, separate things out into horizontal and vertical. But if you're stuck in one column, could be that you're not recognizing that some term is 0 or something, but it could be that you got to go to the other column, get the time, and come back. Okay. And if you find yourself saying, I don't know time, don't say, oh, I got to use don't know, don't care about time, because we care about time because that's the connection between the two equations. All right, so we are going to do this example problem, and then we're done. All right, so here is the diagram. Set up your horizontal and vertical Sudoku, and then we will compare answers. We'll fill everything out, and then we'll compare that. Okay, so horizontally, you did not have the rock did not have a head start, so we can call that 0. Its initial speed is 5.5, and there's no jetpack, so acceleration is 0. Vertically, it did start with some height, but no up. So the mistake people make is to put that 5.5 here as well. But the Earth is pulling it down. Otherwise, it would travel on at 5.5 forever. Okay, so that's the Sudoku. So we drew a diagram, we set up the Sudokus. Find the time in the air. All right, so when it hits the ground, it no longer has altitude. So that means y final equals 0. And that's a hint that we're going to use the vertical to find the time in the air. So let's do that up here. So you got your whole position function. You hit the ground just like the baseball lab. You started with some height, but no ups. And then 9.8 over 2 is minus 4.9 t squared. So t is the square root of 16 over 4.9, which is 1.81 seconds. So then that time goes in both Sudokus. Okay, that's B. And then how far from the cliff did it land? So we're looking for this. Sometimes textbooks will call that range, like a firing range. It's the opposite of math, where this is domain and this is range. But think of it like a firing range. Okay, so how far from the cliff? That's basically saying what is x final. Okay, so x equals x naught plus v naught t plus no acceleration. And it doesn't have a head start. So it's just heading over, just like the Joker in the demo, heading over at 5.5 meters per second for a total time of 1.81 seconds. And that gives you 9.94 meters. Okay, so pretty straightforward problems. But just introducing you to make sure you have no acceleration here and no velocity there. I do recommend that you still do some practice. There's some practice problems all mixed up at the end of this module.